Hello. Yeah, so today we will try to cover some of the important concepts on the Selenium side, and I wanted to cover this topic explicitly because this is very much important, and probability is high in the interview that they will ask a lot of technical questions on this area. So it is also important that we understand technically what is happening inside a WebDriver exactly. What are the concepts, different concepts from Java that we are using inside the WebDriver whenever we are writing a WebDriver script. It is also important that we understand what exactly are we writing and how is the Java concept being covered in that particular script. Okay, so yeah, so I'll cover it from the standpoint of Java as well as Selenium. So how is it related? Okay, all right. So before I explain this, I just want to go ahead and just show you the script. All right. So here what we have typically in Selenium, right? When we define a WebDriver, when we write a Selenium script to open a browser and do some actions like send key or click or whatever it is. So how do we do? Normally, we define a WebDriver, okay, object, and then we use that object, driver object, to get a website. So this is a web URL we're getting it. It opens up a browser, and then we specify find element. We give a locator, okay, and some ID or XPath or CSS, and then we try to send some keys like some text. Okay, this is typically 2-3 lines of code for Selenium. Okay, but we need to also think about that technically, that what exactly is happening. Why do we normally have to define like this, and how does all this WebDriver inside this WebDriver code, how is it actually implemented? On an overview overall, cannot go so much in depth into the topic because it's a huge project and it's a huge Java project, and to understand it we need advanced knowledge. But again, let us try to understand on a basic point of view what exactly concepts are being used, how exactly is it working actually. Okay, so in interviews they might ask you a couple of questions regarding this, that what are the Java concepts that you use in your test framework. So WebDriver is a very nice concept where we can tell them almost every concept we can tell them using WebDriver. Okay, so we'll see what is this happen, what are these concepts that is being used in WebDriver, and let's go back to our slide. So yeah, so we will try to dissect this, investigate this line. So what is happening here? WebDriver driver equal to new ChromeDriver. So basically, WebDriver driver is a reference variable, and it's a type of WebDriver. WebDriver is an interface. Okay, that is coming from our Selenium library. And then by this, what do we mean? That new ChromeDriver, meaning we are creating an object. So ChromeDriver is a class. Okay, so we are creating a new object of ChromeDriver class. So here in this line, we are creating a new object of a ChromeDriver class and assigning to WebDriver interface reference. Okay, so let's see what are the concepts involved here. Here, some of those concepts that we need to know. Interface. Okay, interface concept you need to know. You need to understand what is interface. Okay, how does it work? Basically, interface, right? That interface is something that defines some kind of rule. Okay, and those interfaces can be implemented for the further classes, and those classes has to define the implementations. Okay, so we cannot create a object of an interface. It's like you cannot do like this. Let me try to do like this. Let me try to do, and here I will try to like this. What am I trying to do? I'm trying to actually create an instance of an interface. This is the interface, and I'm trying to create a new object, new interface. It won't work because we cannot say the WebDriver is abstract, cannot be instantiated. So interface are by default abstract. So we cannot actually create an object of an interface. That's what I'm saying here. So we cannot instantiate interface. Okay, clear. We can instantiate classes. Okay, fine. So interface has abstract methods. Okay, means they do not have body. Meaning the interfaces are nothing but if you go to interfaces like WebDriver, So you won't see any implementation. It's just that method name kind of this. Okay, there is no implementation, no other coding, simply only the method names. Okay, those classes who are implementing these interfaces has to define their implementation. Okay, that is the concept of interface. Next, let's go to the next concept, inheritance. What is inheritance? Normally, there will be a parent class and then there will be child class. So parent class will have some methods, some variables. Child class will have some methods, some variables. So if we want to build a relationship, is a relationship. For example, we want all the properties of parent class to be inherited in the child. Then we use inheritance. So in Java, we use extends or implements as an inheritance concept. Okay, so whenever we need all these properties of the parent class, we use extend, and the child will have all the properties and methods of the parent class. So that's what inheritance is. Okay, so in the inheritance, there is another also concept called typecasting. So it is this typecasting is very important to understand if we want to understand how WebDriver works. Okay, so what is typecasting? Typecasting meaning converting one object of a class to another reference, meaning so one type to another type, you can say. Okay, so what happens is that when we not this one. Okay, yeah. So what we do when we create an object of a class and assign it to a reference of a superclass. For example, this is a superclass and this is child class. So we create one reference, meaning this is how we are creating a reference. This is a reference. So this is a, so let's say this is an interface and this is a super interface. So it is a parent. So we are creating a reference and we are assigning a child. So here ChromeDriver is a child. So it's a child class. So we are creating an object and assigning to this reference. Okay, that's what it is saying here. When we create an object of a class or interface and assign it, or create a child class, okay, and assign it to a reference to superclass. I would say class, and assign it to a reference of this superclass or interface. It is called upcasting, meaning this object we created and assigned it to this interface. So it is like upcasting. We are upcasting it. Okay. Now we cannot do reverse. So opposite, we cannot do that. So we cannot create a reference of child and create an object of parent, because here this interface you cannot create it. You cannot create an instance of interface itself. Even though it is a class also, if you do a downcasting, it will throw error. We'll see how it. Okay. So the next point, when we cannot do the vice versa. Okay. So in typecasting, there are two things: upcasting and downcasting. If you look at this image, it's happening like parent and child we have, and child is extending parent. So there is a parent-child relationship. Now we are creating one reference of a parent like this, parent P. So it's a reference, simple. And we are assigning this child class object. So we created new child. So this class object we have created and assigned to parent. Good. So this is called upcasting. By default, it is called upcasting, meaning what you are trying to say is that you create a reference of a parent and assigned a object of child class. So now you are using P as a reference, and you can use P to access all the methods and variables from the base parent. Okay, remember that using this P reference, because it is an upcasting, and upcasting restricts to use any child class methods and reference. Here with P is nothing but a parent class reference. So with this, you can only access parent class methods. You cannot access any methods from child class in upcasting. That is one point. Next, we are trying to do vice versa. What we are doing is we are creating a child class reference and we are creating parent object and assigning it to child. So here, see, we will get a compile time error. We'll get error there and there itself, because this is, we are trying to do downcast, opposite of it. Okay, because this is a parent. How it became parent? With extends. This decides who is parent, who is child. So in child we are doing extends parent. So this they became parent and child. Here we are creating reference of child, but we are creating an object of parent and assigning, trying to assign it, which is not possible. Okay, but there is a trick. What is it? So this is direct downcast, but there is another way that we can do. How? The same thing. So for example, we want to downcast it. What is the way to do it? First, we have to create the parent reference and assign this child object to parent. Fine, upcasting is done. After that, see, this is first step. In the upcasting also we are doing it. First, we need to do the upcasting. Done. After that, create a child reference, just like this. Okay. And rather than creating, assigning to new parent object, simply typecast like this. So here, the parent object already upcasting is done, right? So we have already reference of parent. So we can use this parent to assign this child class. So assign this parent to child class, but here also mention in the bracket child. That means you are telling Java that parent P is a reference of parent and new child is assigned as object. That is fine. Till here it is good. The moment you try to create child class reference and assign the parent, it will complain. But to tell that no, this parent is already existent, it is already referenced here, then you can do like this. Within the bracket, you can tell that child. So it is you are downcasting this parent reference. Okay. So with this child, now what you can do with this child reference, you cannot access all the parent method, but only you can access child methods. Okay. Let's see in action. Okay, so let's try to understand here. Maybe I have the code already. So this is the code. What's happening here? Let's try to understand. We have a super class. It's nothing but a parent class. And it has two methods, super show and super print and super show. Okay, two classes. Fine. Next, we have a child class that's called subclass. And this is extending super class. Okay, the moment it extends, automatically our subclass will have this method accessible. Okay, but again, subclass has two more methods. One is subprint and subshow. Okay, and also subclass has another method of this. This parent class has a super print. So here we are overriding it. See, there is an overriding concept here also in the Java. So we are overriding super print in subclass. That means if we are using the object of subclass then and calling super print, it will not go and print this. It will go and print this because we have overridden it. Okay. So far in subclass we have two on its two child class, so subclass own method, subshow, subprint, and one is overridden from the parent class. Fine. So let's try to see what is happening here. So this is what upcasting is. We talked about upcasting, right? Upcasting means create a reference of superclass, nothing but a parent class, and assign the object of the child class. Is nothing but our child class, subclass, which is good. This is upcasting. Done. So with this reference, what you can do, you can access superclass methods. These two methods you can easily access, but you cannot access any of these methods. Subprint, subshow, you cannot access it. Okay. Okay, so how to see that? Let's see. Yes. So this is what the exactly same thing we have done. Superclass, superprint, supershow, subclass, subprint, subshow, and one override method. Fine. So here I have a simple test method just to print something. So what I'm doing is, first thing, let me try to print it. Okay. So if I print I'm inside subclass. Okay. I'm inside subclass and I'm trying to print superprint method just to see whether it is printing our subclass overridden method or it is printing our superprint parent class method. Let's see. So technically, because we have overridden this method, which is also present in our parent class, it should print this. Okay, you see here at the rate override. This is a way to tell that this is the overridden method. Without this also it should work. It's not mandatory to tell. Let me comment it out and let's try to run only this. Wait for it to run. It is running. So basically, because this is the overridden method, it should print this one, not this one. Take some time. So super overridden in subclass. So this is the one that got printed. So we know now that this overridden method, if we are using in subclass or subclass object, it is going to print this, not that one. Okay, that is one concept. In the next, what we did, we created a reference of a superclass and assigned an object of a child class. Fine, this is a upcasting. Okay, so using this reference, if you see here subclass dot, we can see only super show and super print. We don't see this sub print and sub show. Why? Because we have done a upcasting. In upcasting, you can only access the parent class objects, okay, methods and variables, because this is upcasting. So there is a limitation that you cannot access your child class methods, and also because this the reference is from parent class. Okay, so upcasting we are clear. Second, downcasting. To do the downcast, what we have to do is similarly we have already created a reference and assigned this object of a subclass. So upcasting is already done. So this step plus now we have to perform another step. So let me, for a clarity, let me do one thing. Superclass 2 I will do. Okay, this should be superclass 2. So what we have done, step 1 is do upcasting. So create a reference of parent class and assign this subclass object. Upcasting is done. After doing the upcasting, what we have to do is we have to create another child class object. Okay, nothing but a subclass and subclass 1. And let's see, I'm not doing this now. So I'm doing it vice versa, upcasting vice versa, exactly opposite I'm doing it. Creating a subclass reference and assigning this superclass. So if I do like this, new superclass. So this is exactly opposite of this upcasting. So I cannot do that. I told you, right? You cannot do that. Using child class reference, you cannot create an object of superclass or parent class and assign it, because it is not possible. See, it is saying that a required type is a subclass. You have created a reference of subclass, so you need to give a reference of subclass only. So you cannot do that. Instead, what you can do is superclass subclass object. So here already I have created superclass. Okay, nice. So here Java is complaining again. So what I have to do here is that I want actually this superclass object to be available on subclass. So this is downcast. So how can you do downcasting? Here, this superclass reference you cannot use directly. Okay, so what you can do is that, okay, not this. It should be subclass. So we are using this same reference. Okay, we first have to do upcasting. Once upcasting is done, if we don't do this, it will complain that it says that it doesn't require, it is not recognizing it. So to recognize it, because we are doing a downcasting, so this is a superclass reference. and we have to downcast it to subclass. So we have to provide this subclass within the bracket. Okay. And this is done. So once you've done this downcasting here, right, step 1 upcasting, and this is the downcasting. Here using the same reference, but within the bracket you are just calling the child class to which you want to downclass. If there are multiple child class and you want to downcast it to subclass 2, subclass 3 or something, you have to give this subclass name to which subclass you want to downcast this reference. So once you give this reference, you are telling that, see, this superclass reference is already assigned with subclass object. Now what you do is use this same subclass object and downcast it. So using this subclass one, what can I do? You see here, I can access all the subclass methods, sub show, sub print, right? These things, these two I can access now. Sub show and print I can access. Can I access super sprint? Let's see. It is there. Super print is accessible. Why? Because it is not coming from a parent class. It is because we have overridden it. That's the reason it is coming here. Okay. So this is the concept of upcasting and downcasting. Why is it important? Why is it related to the WebDriver Selenium? Let's go ahead and see. Upcasting, we got it. Now let's go to try to understand this concept. So WebDriver driver record new WebDriver driver record new ChromeDriver. We write it right like this. So what is happening? This. So let's see what is WebDriver. Where WebDriver is coming. So if you see WebDriver is an interface, okay, WebDriver is an interface, okay, in this entire hierarchy. And this interface, because this is an interface, it will have unimplemented methods, right? Interfaces will not have implemented methods. It will have only unimplemented methods. So some methods are like get, quit, right? So if you see here, this method get, it is coming from this interface, okay, because it is defined here in the interface. Okay, so you can directly use this dot get. So driver dot, when you see, you get the get method. It is coming from the interface. Similarly, quit also you can get. Fine, this is the interface, we got it understood. But there is on top of it, there is another interface, and this is search context interface. And this is the highest level of the interface present in Selenium. There is no other classes or interface on top of it. So this starts with everything on your Selenium starts with this. So search context is another interface that again has unimplemented methods like find elements and find element. Only two methods are present in search context. If you see here, the moment I'm doing driver dot, then find element and find elements, I will get these two. These two are coming from source context. Okay, fine. So source context is another top interface and it has only two unimplemented methods. And WebDriver interface, another interface, which is extending this. So because this is interface to interface, and this is the parent interface and this is child interface. So how do we know? Because extend keyword is there. So interface to interface, if you want to make a parent-child relationship, we have to use extend. So when you do extend, that means in WebDriver interface, we have get and quit on its own, plus by default, the inherited methods will also come. So now after extension, WebDriver has two more methods, find elements and find element, correct? So now WebDriver we have get and quit. That's why when you create a WebDriver equal to driver, with driver you can use get also, you can use find elements also, because this find element is coming from source context and WebDriver has extended that. Now we got it. This is parent, this is child. Next level, let's see. After this WebDriver interface is again used by remote WebDriver class. Okay, there is a class called remote WebDriver that will implement this interface. Why implement? From a class to interface, if you want to build a parent-child relationship from class to interface, then you have to use implements, because this is an interface. From class, if you want to build a parent-child relationship to another class, then you can use extend. Okay, so here what we are trying to do is remote WebDriver is another child class which is implementing interface. So by this, what happened? Because this is a child of this, so these two find elements and find element method and this get quit and whatever other methods are there, those are available here. Because a remote WebDriver is also implementing this interface, by default this becomes a fully implemented class. So this class has everything: get, quit, find elements till here. And these are interfaces, right? Because there is no implementation, and our remote WebDriver has all the implementation of these methods, meaning all the codes that is needed for this method to perform are written in remote WebDriver. So what do we understand is that these are only the interfaces. There is no actual code present here. They are only setting some of the rules, like you need to define your implementation on your own, but they are setting the rule. You have to implement all of this. So that's what the parent-child relationship is there, inheritance is there. So remote WebDriver is actually the critical class that has all the implementations of these methods. Okay, now let's understand one more step. So we have again another class called Chromium Driver class. Okay, Chromium Driver class again extends this remote WebDriver class. So this is another child. See the hierarchy: parent, child, child, child. So we have come down till 4th level. Okay, Chromium Driver is another class which is again is extending remote WebDriver. What does that mean? This Chromium WebDriver will have everything that remote WebDriver has. And what remote WebDriver has? It has everything that WebDriver has, everything that such context has. So Chromium remote driver, and then we have Chromium driver. Now Chromium driver class, again we have more child classes. And see here we have Chrome driver, Firefox driver, Edge driver. So everything, any driver that you name, any browser driver you name, that is a direct child of Chromium driver class. So now we understood, right? So now at this level, at this child level, what do you think? Child Chrome driver, Firefox driver, Edge driver will have all the inherited properties of their 4th parents, right? These are all inheritance. See how inheritance is going down one step by step. So Chrome driver, Firefox driver, and Edge driver has all that methods and properties of their inherited parents, correct? So if you go to code back again, now how do we understand it? WebDriver driver is an interface, and we are assigning a new Chrome driver class, okay? And using this reference to get a website. Now, instead of this, we can also do like this. Instead of Chrome driver, you can use Firefox driver. Okay, let's call it as driver 2, and let's call it as driver 3. And instead of this, I will use Edge driver. See, this is interface, this is a parent, and we can create as an object of child and assign it to this parent reference. So this parent has, we have 3 reference: 1 driver, 2, 3, and this child has their own objects we created, and we assigned it to WebDriver interface. So what is it? The concept upcasting. We understood the upcasting concept, right? So by doing this, what we are achieving is, whenever we are upcasting WebDriver with Chrome driver, then we are able to access all that methods that WebDriver has. WebDriver has find.elements, WebDriver has get, right? So we can use with this driver1.get we can do, and similarly so we can use driver 2 also, we can use driver 3. So what does this mean? Now, by doing this, by actually using the WebDriver reference and assigning the child class, what are we achieving? We are actually achieving upcasting, And through upcasting, we are able to access the methods of these interfaces. See, get belongs to WebDriver interface. Find elements belongs to WebDriver. Again, it is coming from source context, right? So we are able to actually use these methods using this WebDriver interface reference. Now, why we are using this and not using this? We can also do like this. Instead of this, we can do, no need to create this. We can directly create a ChromeDriver, and this is ChromeDriver C, I will say. See, I have created simply an object of ChromeDriver, because ChromeDriver is a class, and I can create a ChromeDriver object. Okay, with this also, ChromeDriver C also, I can do this. The same thing I can do. There is no problem with it. But what is the problem here? Because we have only created the ChromeDriver object, and with that object we are happily going and accessing that get and find element. That's fine, because this is now not coming, this get is not coming from directly WebDriver. It is coming because ChromeDriver is an inherited child of WebDriver. That's why ChromeDriver is able to get it and find element. But the same thing will not work in Firefox driver. So this code will work fine only for Chrome browser. It won't work for Firefox browser, because there is no object created for Firefox. For Firefox, this is what it is going to work, because this driver 2 is coming from WebDriver. WebDriver is nothing but a parent. So that's the reason we don't directly create the child class object, because with one references we can actually use the same reference and create, just assign child object, and same code will work. That's the reason we don't create like this. Okay, so here if you see, WebDriver driver is just a reference, but type is same. All are same type, WebDriver type. So all these three code are same only. So you can use this line of code just by changing the child object type. If you want to run Chrome, then just assign this ChromeDriver to driver. That's it. So no need to do anything else, right? All these things are not necessary. I want ChromeDriver, then just create a ChromeDriver object, assign it to it, and it will work. I want Firefox driver, create Firefox driver and assign to it. The same code will work. So what is the benefit here is that we don't have to write separate code for each and every driver. Only one thing we need to change. If we want to change the browser, only create a browser driver object and just assign it to it. That's it. All the code related to driver will work. Get, find element, click, all that, anything that you know in Selenium should work. That's the benefit here by this upcasting concept. That is what this entire hierarchy is important to understand. So this is what the hierarchy is: search context interface, WebDriver interface, then remote driver, then Chromium driver. We have remote WebDriver, then here Chromium driver 1. Our interface should come. Okay, and then these are the child of element. Okay, so there is also web element interface, right? There is also a web element interface that also has the same, that web element interface also extends in these interfaces. Take screenshot and search context. So this web element interface also, this remote web element class is there. Similarly, the same concept. Okay, so how does this web element come here? So whenever we are doing this, right, find element, and then this find element is nothing but we are using a web element. Okay, so this find element is a type of web element. Find element is nothing but a data type is a web element. It's a web element type. Okay, so that's the reason all this web element also similarly same kind of hierarchy is itself. It is also extending screenshot. So here also if you see, remote WebDriver also implements text screenshot interface and JavaScript executor interface. There are two more things are there. Whenever you try to take a screenshot, this text screenshot interface has that method to take the screenshot. But again, if you want to take the screenshot, what you have to do is you have to create a a reference of WebDriver driver, and then assign one Chrome driver or Firefox driver, whatever it is, and then you have to downcast it, because this text screenshot is a parent one. Remember, if the text screenshot has a screenshot method, and if I want to use that method, I have to downcast this, right? We talked downcasting right here. So if I have to actually use this method, which is present in parent, then I have to downcast it using Chrome driver. Then only I can use it. So we'll see this concept maybe sometime later for this screenshot. But this is the overall hierarchy with respect to Java concept. Okay.